Recording is rolling. It is Thursday, April 4th. I have a circuits lab lined up for you guys, so I'm going to do a few demos up here so you guys know exactly what's going on. After that, I'll send you guys back to the lab area, have you guys construct some circuits with these Christmas lights, right? Each Christmas light, it's a resistor, right? Construct at least 3 circuits with 3 bulbs each. You guys in front of you have this lab page. You guys see this lab page? Oh, there's 1, 2, 3 spaces per circuit. So you draw a schematic of whatever circuit you're making, and then an attached Kirchhoff table. Now, some of these Kirchhoff tables are a little bit bigger than you need, so you don't have to use every single row in some of these, right? But use at least 3 bulbs, or at least 3 resistors on each one, right? Also, you guys, well, when you head back to the lab area, you're going to get these multimeters. So I'll show you guys exactly how to use these multimeters. Also, you can directly measure what is the voltage drop across each resistor and what is the current through any resistor for the circuit, right? And then you can use those measurements to calculate what is the resistance in ohms of a single resistor and what is the power in watts, right? That'll be the rest of this Kirchhoff table, right? Resistance in ohms, potential difference in volts, current in amps, power in watts. I guess get that, right? Maybe I'll kind of spoil this a little bit. Each one of these bulbs should be somewhere between 1 and 1.5 ohms. So somewhere between 1 and 1.5 ohms, right? If you're getting approximately that, then you're probably in the right path. Okay? Right. And then, across the voltage source, right? Which you guys also back there have cell phone chargers, right? Right. Right. Now, what kind of circuits could you guys wire up? Whatever circuits you make, I'll do some examples for you guys. Whatever circuits, go ahead and draw the schematic out on the left side. You guys see a blank space for some circuits schematics, right? And what could you make? Well, here's a whole page of opportunities right here. So last couple of days, we've been working on this page, right? Well, double-sided, right? So any of these would be good candidates. And I've got 3 wired up, so I'll show you guys 3 examples. You could just copy my examples if you like, right? I'm going to do this one 3 in series, this one 3 in parallel, and this one kind of hybrid, right? There's 2 in parallel connected with 1 in series. Right? So those are the 3 I'm going to do. Right? Speaking of this page, let's bump the due date to Monday. So, and some students have already completed both sides, right? It's really 2 assignments, right? Some students have completed both sides. If you do, you can turn it in the grade tray, be done with it, right? But if you need extra time, then yeah, let's just bump that to Monday. And then tomorrow, what tomorrow's going to be is finish anything you haven't finished yet. So most students will have finished this lab by the end of today. End of today. If you haven't finished this lab today, then hold on to it. And tomorrow I'll leave all the lab equipment back there, and you'll have all the lab equipment. Okay. Or tomorrow, if you want to work on these circuits or ask me any questions about the circuits or Kirchhoff tables, then that'll be tomorrow. So tomorrow will be finish anything. Okay. All right. My AP students, I'm having them bring in a laptop tomorrow so we can do a practice exam. All right, let's do some examples. All right, outlet, guys. How many volts? How many volts is an outlet? 120. It's 120 volts alternating current, which is dangerous. Do you want to go stick in pencils and paper clips in here? No, don't do that. No. The answer was no. Don't. The only thing you're going to plug in the outlet is this cell phone charger. Now, this adapter will step it down to just 5 volts direct current. So now we're down to 5 volts direct current. I can touch the leads and look, no shock, anything. All right, so that's safe. 5 volts direct current is safe. Okay, let's wire some circuits up. I'm going to start real simple with just 3 in series. So if I do 3 in series, I would draw the schematic on my paper, and I would wire up. Where's my 3 in series? Is that this right here? You guys see that? It's the same thing. You guys see it's the same thing? Right. Here's my voltage source. That's my 2 leads. Right. So like that. Let's see what this looks like. I also have alligator clips back there. Alligator clips. Right. Could be helpful. Okay. So let's hook this alligator clip right here. Bam. Right. And alligator clip right here. Bam. And look, they're all on and they're fairly dim, right? So 3 in series are going to be kind of dim like that, right? Right. Good so far? Right. Now what? Right. Now multimeter time. Guys, everybody's paying attention. Up here because there's a lot going on with this multimeter. So there's 3 places to plug in these leads. You guys see that? Now, the black lead is in COM. I'm just going to leave that right there the entire day. But this red lead, it depends what you're trying to measure. So I'm going to take this red lead. I want to get voltage, so I'm going to pop it out here. Get out. And switch. This one says volts, ohms. So I'm going to pop it in here. Right. Everybody look up here. Everybody see what I'm doing? Right. So I pop that in there. I'm going to switch this toggle to anything on the top left is DC volts, direct current volts. But watch the decimal place move. You guys see tenths place, hundredths place, thousands place. So like how precise do you want to get? Maybe I'll leave it there. I think it's pretty good. Okay. Or you can do this one. Actually, either one of those is okay. Okay. Right. So volts DC. Right. Right. Now, how am I going to measure volts DC? Well, you got two places you can look. On your lab paper, I showed you guys how to connect a voltmeter. Now, the voltmeter you connect in parallel with whatever you're trying to measure. What is the voltage drop across? Because you're measuring a potential difference. It's like if you're measuring the height of a waterfall, you need the top and the bottom so you can get a difference. And then here's how many volt potential difference. Versus later on, we're not at this yet, but when you measure the current with the ammeter, notice how I broke the circuit open and I'm forcing the current to flow through the multimeter, right? Which is different. Now, we're not at that one yet. We're going to start with the voltmeter. Also, I made a whole poster for this. So if you see the poster in my room, it looks like this. It's the same thing. I said too. All right. So I'm going to get volts. Right? I got that wired up for volts. I got this toggle switched to volts. Everything's ready for volts. Right? Take my two leads. Maybe I want to know what's the voltage drop across the entire thing. Guys, what should it be before I even connect it? Guys, if I have a 5-volt cell phone charger, what's the voltage going to be across the entire leads? Should be 5 volts. Let's see if it's 5 volts. 4.8. That counts. 4.8 volts. Right, so we're a good start, right? What do you think it is across one resistor? Do you think it's about a third of that? Guys, what is a third of 4.8 volts?
Like 1.6.
1.6. Right? I could do it across this one. 1.6 volts. I could do it across this one. 1.6 volts. Hey, you guys see that? Right? It drops 1.6 volts at a time. You see that? Right? Hey, and so I would record all that on the table. Right. Now I need to figure out what is the current in amps. I'm going to make some changes. You guys want to see some changes? Pull out this plug. Switch it over here. So one says amps. Also switch this toggle. I'm going to switch one that says 200 milliamps. I'm going to just treat this as amps. Okay? You guys got that? How many amps? Okay. And the other change I need to make, that was 2 changes so far. Switch that. There's 1 change. Switch the toggle. There's 2 change. Also, I need to break open the circuit and connect this multimeter in series with the rest of the circuit. Notice the bulb's turned off. Look, my bulb's turned off. Right? But they won't say off. Let's see what happens when I connect this right here. Oh, whoops. Connect that a little better. Bam, they're back on 1.3 amps. You guys see 1.3 amps? Okay. Now, since that's current, that's a flow rate, is that 1.3 amps through all of them? Yep, it sure is. That's 1.3 amps for the whole circuit, but also for each individual bulb because they're all in series. Okay, you guys got that? So that could complete that entire column for that Kirchhoff table. Okay, hey guys, if you know, we just found what is the voltage drop across each bulb and what is the current through each bulb. If you know voltage drop and you know current, can you calculate the resistance? Right. Let's do that real fast anyway. Right. Because I could switch that around. I could get R equals V over I. So let's take 1.6 volts across a single resistor, and there was what was it 1.3 amps? Is that what it was? All right. Oh, look at that! It's exactly what I told you. Remember, I said somewhere between 1 and 1.5 ohms. That's like 1.2 something ohms. Okay. Right. And all these light bulbs will be approximately identical. Right. Right. So you guys good so far? All right. Let's try a different setup. Let's do 3 in parallel. You guys want to see 3 in parallel? All right, so there's my schematic for 3 in parallel. And here's exactly what it looks like. Look, 3 bulbs. I tied all the left ends together, tied all the right ends together. Right? And let's see what is this going to do. How bright do you think these are going to be compared to before? Yeah, really bright, you guys think?
Yeah. Oh yeah.
Ooh, look at that. Crazy bright. Crazy bright. Okay. Let's switch this over to volts. Let's do volts here. Get my leads going. Switch this to volts. Right. How many guys, how many volts do you think? How many volts? 4.8 or 4.9. Okay, so basically the same as before, right? Okay. Let's do amps. So switch this plug over there, switch that toggle. Right. I need to break open the circuit. Now, guys, how many amps do you think now compared to before? More or less or the same?
More.
More? You say more? Right? I think that's a good guess. They were all really bright. Right. 3 and 3 parallel makes the resistance really low, right? 6.7 amps. You guys see 6.7 amps? About? Wow, right. Now, what about each individual current? Do you think it's okay just say divide by 3 and it's about a third of that through each one? Right, because the current splits 3 ways, right? You guys get that? Right? So you can kind of figure out from there, right? And then finally, let's do one a little fancier. How about this guy right here? Right, where I got 2 in parallel with each other connected to 1 in series, and then that all connects to the leads. Right. Where have I got that wired up? That's this one right here. Right. You guys see these 2 in parallel with each other, connected with this guy in series. So that is that. It's the same thing. There's my schematic. Here's the actual. Okay. What does this look like? Wired up. Let me show you guys. Okay. Or let me ask you guys before I hook it up. Do you think they'll all be the same brightness or different brightnesses?
Different.
Different, right? Different. And what's going to be bright? What's going to be dim? Yes, exactly. Series should be bright. Let's see if the series is bright. Here's my positive. Here's my negative. The series is really bright, and the 2 in parallel, they are on, but just barely, right? They're really dim. You guys see it too, right? And you can, of course, use the multimeter, say what's the voltage drop, what's the current through any place. Okay. Right. So you guys good so far? All right. Of course, right. So quick reminder with these posters, right? Connect the voltmeter in parallel, you look for a potential difference. Connect the ammeter in series, you have to break open the circuit to get the current flow. Right? You can use Ohm's law. If you have measured current and voltage, you can calculate the resistance. You should get about 1.2-ish ohms per light bulb. Okay. Oh, you could also use Joule's law to calculate what's the power in watts. Can you guys do that? You guys do that? All right. So for your lab, draw 3 different circuits with at least 3 bulbs each. You might not use this entire tab. These are okay. So if you stop like right there or something, that's okay. Right. If you finish the 3 circuits and you fill out the entire Kirchhoff tables by the end of today, you can turn that into the gray tray. If you don't finish this by the end of today, then tomorrow is going to be finish anything you haven't finished day. So I will leave all the lab equipment back on the lab table for tomorrow. And if you need to finish that, or if you have any questions about anything we've done this week, then tomorrow will be that type day. All right, you guys good? All right, so everything you need back in lab area. I will walk around, help you guys out. Also, tidbit, if you can get hold of an orange multimeter, those tend to work the best.